Hi, I'm Bob Tabor with LearnVisualStudio.net. In this lesson, we want to backtrack and learn about the new async features of C# 5.0 and figure out what those new features accomplished in our load local data async method. So you can see here that I have it. It's about line 337 in my source code. So I want to start at a high level and talk about your app. When your program launches in Windows, it's executed in a process, which is simply an isolated sliver of the computer's memory and CPU. Each process is kept separate so that if one process goes bad due to a memory leak or the processor is busy running some other long-running process or so on, it shouldn't necessarily affect the other processes, the other slivers of CPU and memory. So each process owns a thread of execution. A thread is an execution path that can work independently of other execution paths. So when you create an app, by default, your app is single-threaded. Usually that's not a big deal until you're trying to perform some long-running task. So for example, retrieving data from a text file definitely qualifies as a potentially long-running task, depending on the size of the file. Let's suppose, for example, instead of just a dozen or 2 dozen entries like our recipes.txt file has, what if it had thousands of entries? Then it could take several seconds to access the file, load into memory, and then parse through the file and create instances of the recipe data items and the recipe data group. So it has the potential for a long-running process. So while the app is busy processing that file, the app is essentially just frozen, at least from the user's perspective. The long-running process blocks anything else from happening until it's finished. This is an example of a synchronous operation, which means that the operation does most or all of their work before returning to the caller, to the code that actually called the method to begin with, all right? So when building Windows apps, you want to make your app fast and fluid, meaning if your app is doing tasks that can take a long amount of time, the app should still be responsive during that task and even report back its progress as it's working so users know that the app hasn't hung or crashed. So to keep the application responsive, we can make the methods execute asynchronously, which means that each operation does most or all of its work after returning to the code that called it, after returning to the caller. So it's essentially saying, hey, go open the file, let me know when you're done, I'll be off working on something else, all right? And so then we basically split off on 2 threads of execution. One is opening the file. Meanwhile, the main thread of execution continues about its work. Once that thread that was spun off is finished, it comes back and says, hey, I'm done. Okay, yeah, I can use your results now. Let's go. And so that essentially, in a nutshell, is how it works. So Microsoft wants to enable developers to build responsive apps. So they've added asynchronous APIs throughout the entire Windows runtime to things like opening and reading files and sending and receiving data from the web or capturing images or video from a webcam camera. In fact, when using the Windows runtime, there are only async versions of the API wherever it was deemed possible that an operation could be long running or blocking, okay? And frankly, async is nothing new, but the problem was in the past creating multi-threaded apps was difficult and it was tedious in that you typically had to register a callback method and build that callback method and then write the code in that callback method to handle what you want it to do when the process has completed. But in C# 5.0 and with Windows 8, instead of using callbacks, you can just use this keyword await to create asynchronous operations like a long-running task that immediately return control to the UI after the async operation has already started. All right, so the compiler does the difficult work that the developer used to have to do. And the added bonus to developers is that much of this happens without a lot of effort on your part. The code that you write still looks and it feels synchronous, like you're already used to. And behind the scenes, it gets all the advantages of asynchronous programming. Pretty cool. So there are, I think, about 3 parts, it seems to me, that require to get this all to work. First of all, as you can see here, the async method has to be marked with the keyword, with the modifier async, meaning that it contains at least one await expression or statement in the body. Now we can see in our case we have 2 of those. Let's get back to that in a moment. Secondly, the async method has to return a type of task or task of t_result, so a generic task that will return a value essentially. More about that in just a moment. And then third, it has to contain one or more await operators, which essentially suspends the execution of the method until the given operation, in this case get file async, is complete. So in this case, we're floating along with our method synchronously until we hit our very first await operator, which in this particular example happens extremely fast at the very beginning of the method. And so at that point, the method is suspended until the task is complete, this get file async. Now in our app, that means that the control is returned to the app.xaml.cs, as you can see right here, that calls our load local data async, and it continues to execute until this entire method has completely finished. All right? So the caller, in this case, this code, can continue on until it reaches a point where it really needs the data that it's expecting from the async method. Now in this case, we're not returning any data that's needed by the rest of the execution path. But when the task is complete, and if it returns data, then the caller can continue on using the new value that was returned from task of t_result. So what exactly is a task? A task is simply some work that needs to be performed, and it will let us know when it's finished. When the task is finished, it'll either be silent or it'll return some value. Here, our task is silent. It doesn't really return anything per se. If it's going to return a value, it'll be of type task t_result, meaning, for example, that if a task of type int were to be defined here in our recipe data source, then we would expect the very last line of this to return some integer value. And so then once this was complete, it would supply that integer value then into some variable that's awaiting it. All right? So in a nutshell, if you're writing a method that'll consume an async method defined in the Windows Runtime API, like we've done here and here in these 2 lines of code, then you're going to need to mark the method as async. Furthermore, you'll need to use the await operator in front of any call out to an async method like we've done here and here. Okay? And finally, your method should return a task so that any code that calls the async method will be able to continue executing and then get the results whenever they're ready. All right, so you're going to see this pattern often as we use the file system, the network, the peripherals, and any operation on the computer that could potentially take a long time and block the main user interface thread, all in an effort to make sure that your app is responsive to the end user, or in Windows 8 parlance, fast and fluid. Okay, so let me show you an article here. I'm just going to open up Internet Explorer. And again, don't forget, you can Bing this title, Asynchronous Programming with Async and Await, on Microsoft.com. This is the best article that I've read. It goes into a lot of detail, and it gives you a lot of hyperlinks where you can go off and learn more. And it even gives you this handy little walkthrough, line by line, and explains, you know, where things start and the order of processing. And so you can see things are jumping all over the place. That's because a lot of the hard work's being done by the compiler based on these keywords that you're adding. And so you're programming synchronously, but behind the scenes, you know, the Windows runtime is handling all the heavy lifting of making this operate in an asynchronous fashion. Okay, so I think we've exhausted most of the topics that are related to the recipe data source. There's probably a little left to do with how items are grouped in the collection view source and the grid view, but I think we'll cover that at some point in the course of what remains in the labs. So we're going to pick up the labs in the next lesson. We'll see you there. Thank you.